Okay, inductive reasoning was the thing. It's like noticing patterns and making us like guessing that might be true, that something might be true. Like these examples. I think the one I used is like every time you come in happy after you take a test, it's because you did well on the test. Okay. So if you come in happy the next day, I would assume you did well on the test or something like that. So inductive reasoning is making assumptions based on patterns, and deductive reasoning is not. Deductive reasoning is making a logical argument based on previous knowledge that has to be true, assuming that your starting points are true. Okay. So what we did yesterday with the proofs, that was actually deductive reasoning. Okay, if we assume that, 2x plus 7 equals 12 is true, then we know for sure what x has to be. That's deductive reasoning. That's algebraic deductive reasoning. The book says deductive reasoning is the process of applying given premises to reach a specific conclusion that cannot be false if the premises are true. Premises, is plural for premises, are assumptions. Kind of like when we talked about postulates are kind of things we assume to be true because they seem so basic. So, which of these arguments is inductive and which is deductive? All squares are rectangles, all rectangles are polygons. Therefore, all squares are polygons. Is that inductive or deductive?
Deductive?
It's deductive. We're starting with the assumption all squares are rectangles and all rectangles are polygons. So therefore, squares have to be polygons. That's deductive reasoning. It has to be true, assuming that the first things that I said were true. The next example, a meteorologist studied weather patterns for the last 10 years in his city. Based on the trends, he predicts an average high of 25 degrees Fahrenheit in January. What kind of reasoning is that? Inductive. Is it definitely going to be true? No, but he's got a pretty good idea of what's going to happen based on past observations. Okay, turn to the top of page 72. Oh, you guys are going to love these words. Modus ponens. You guys see in the blue box where I read that modus ponens? I assume I'm reading that correctly. I believe it's Latin. Says it's a method of deductive proof with the following symbolic form. If P then Q. Okay, so if A then B and A happens, then what do we know should be true? Therefore, B is going to happen. Okay, this means if A is true, then B is true. And they're saying basically A happens, so therefore B happens also. Okay. Very basic. They call it modus ponens. Okay. Oh, by the way, I just wrote a symbol without defining it. This symbol right here is therefore, like in summation. So this has to happen. And then down at the bottom it says modus tollens is a method of deductive proof based on the contrapositive rule. You guys remember contrapositive? So if this is my conditional statement, if A then B, contrapositive, we talked about this yesterday, is if not B, then not A. If this is true, the contrapositive also has to be true. If you brush your teeth, then you won't get cavities, okay? Well, that's not 100% true, but let's pretend like that's true. And then, so if I say it backwards, if I don't have cavities, then what?
I don't brush, or I do brush my teeth.
or sorry, I said that backwards. If I do have cavities, because up here I said I don't, or whoever doesn't. So if I do have cavities, that means I must not have brushed my teeth. Anyways, that was confusing, probably. So, the modus tollens is kind of in alphabetical order. So if A then B, and then not B happens, that means A didn't happen. Does that make sense? If A then B is true and B did not happen, then there's no way A could have happened. So they call that modus tollens. So they're kind of in alphabetical order because, or this is how I think about it anyway. Ponens is like basic. If A then B, A happens, therefore B happens. And that comes before modus tollens. T comes after P, right? Ponens comes before tollens. So tollens is a little more confusing one. If A then B is true and not B happens, then not A happens. So modus ponens, the one that comes first alphabetically, goes with the basic one. And modus tollens comes second alphabetically, and it goes with the little more complicated one. Okay, do you guys remember the transitive property from yesterday? Or was that yesterday?
Yeah, it was not version.
No, it was not Friday.
That was yesterday.
No, it was Friday. It's Friday.
Yes.
Okay. If A equals B, no, yeah, it was yesterday.
Yeah, you was right.
If A equals B,
Who was right?
B equals C, then what?
A equals C.
A equals C. It's connected like a train, transitive property. So they also have transitivity today, which is kind of the same idea. If A then B is true, and if B then C is true, then guess what? If A happens and C happens. So if A makes B happen and B makes C happen, then basically A is making C happen. Okay, they call that transitivity. Kind of like the transitive property. They're all connected, like a train. Train carts are connected. All right, this should be fairly short. That's why I put it on Wednesday. That's why we're going backwards to do it. Okay, number one. So, just to review, inductive reasoning is like a high probability, like we notice things in the past, so we think this probably is going to happen in the future. Deductive reasoning is, I know this has to be true, assuming what we're starting with is true. Okay, number one, so it's inductive or deductive. After surveying thousands of individuals, the Gallup poll predicted the winner of the presidential campaign. Inductive. Now that's not 100% true because, 6 years ago Donald Trump won and he was not supposed to, so.
It was rigged.
It was rigged, yeah, in Donald Trump's favor. And this last one was rigged against him, right? Okay. Number 3, yeah, I'm skipping number 2. In a civil suit, no witnesses testified unfavorably concerning the reliability of the defendant. So the testimony of the defendant was accepted by the jury.
It's inductive, right?
Yeah. So no witnesses testified unfavorably concerning the defendant, so the testimony of the defendant was accepted. Okay, it could be that people testifying don't really know the person very well, and they might be saying he's a good guy, but he's actually not. So it's not definitive proof, but by inductive reasoning, we can assume it's a good chance it's true. Okay, number 5, 2 lines intersect. every line contains at least 2 points. Those were postulates from, or that's a postulate from chapter 1. 3 distinct non-collinear points lie in exactly one plane. That's another postulate. Therefore, 2 intersecting lines lie in exactly one plane.
Deductive?
Yeah, it's a step-by-step logical argument. You might not get the argument, and I'm not going to try to explain it right now, but that is a deductive argument. Okay, number 7. Okay, classify each deductive argument as modus ponens. That was the basic one. Modus tollens. That was the backwards one. Or transitivity. That was the A equals B, B equals C, then A equals C thing. Okay, so number 7. If A, then B. If B, then C. Therefore, if A, then C. Which one was that? Transitivity. Okay, if I do number 9, I just realized that by elimination you could probably figure out number 8. But let's go ahead and do number 9 anyway. If A, then B, not B happens, therefore not A.
Modus tollens?
Right, it's the backwards one, so it's the second one alphabetically. Modus tollens. Does my alphabetical order trick help you guys remember? Hopefully you processed it. Number 11, okay, we're still doing like those 3 options. Still same directions. If I break my arm, then I will go to the hospital. So that's like your if A then B part. If I break my arm, then I will go to the hospital. Then it says, I broke my arm. Therefore, I went to the hospital.
Modus ponens?
Yeah, that's the basic one. That's the kind of repeating the if-then statement, right? So it is modus ponens. Modus ponens. If you don't know how to spell it, it's up in the directions.
Mr. John? Oh gosh. Did you start as a freshman on the football team? Wait, what school did you go to? Is it
I started playing in 7th grade.
No, but did you start as a freshman?
Start as freshman. No. I didn't start till my junior year.
Oh.
But
What school?
I also didn't have 12 guys on my team either.
What
So.
school did you go to?
It was in Kansas. It's called Central, but
No.
no. Let's see.
We actually have 16 people.
We had we played 11 man. We had about 22, which was small for 11 man, but like we had enough to. Anyways, why are we talking about this?
See, you got distracted.
Yeah. Okay, number 13. A good definition is reversible. John's definition of parallel lines was good. Therefore, his definition was reversible. Okay, if it's restating the if-then statement, it's the basic modus ponens one. If it's modus tollens, it's the one where there's a lot of knots. Like it does the negation of the second part implies the negation of the first part. Unfortunately, 11 and 13 were the same thing, weren't they? 15, this one's not modus ponens. 15, if you study for your geometry test, then you will get a high score on the test. If you get a high score on the test, then you will get a good grade on your report card. Therefore, if you study for your geometry test, you'll get a good grade on your report card. See how they're all connected? That's the transit, they call it transitivity. All right, 17, this is the last section. What time do we get out on these days? I think we get out at 10 till?
I think probably.
10:50?
Yeah.
Are you just saying that?
No.
Oh, you can see the wall.
Yeah.
All right. State a valid conclusion for each set of premises, then classify the deductive argument. So we're still putting like modus ponens, modus tollens, transitivity, but we're also finishing what's the natural conclusion that comes from this. All right. So on 17, if a triangle has two congruent sides, then the triangle is an isosceles triangle. We're going to do that in a later chapter, triangles. If triangle ABC is not isosceles triangle, then what do we know? Does not have two congruent sides. That's the conclusion. What number is this? 17. The triangle does not have two congruent sides. What kind of logic did we just use? Modus tollens, right? That's the backwards one where you say not stuff. Okay, number 19. If you are running, then you are exercising. If you're exercising, then you're burning calories. Therefore, what? No, that's the second sentence. Right. If you're running, you're exercising. If you're exercising, you're burning calories. Therefore, if you're running, you're burning calories. Okay, so this one, I don't know if you noticed, all these are connected. If you're running, you're exercising. Exercising, burning calories. So when they're all connected in a train like that, it's called transitivity. Is this kind of making sense?
Yeah.
For a couple people maybe? Okay, 21. A concise definition avoids unnecessary words. Your definition is concise. Therefore, what? You avoided unnecessary words. Your definition avoided unnecessary words, I guess. I spell unnecessary right. One S, two S's. And what kind of logic did we use?
Normal one.
Yeah, the basic one. We just kind of restated the thing. Modus ponens.